Alright, so let's go ahead and try to solve more ziglings, right? And I guess the next one is for optionals. So we are pretty much halfway, I guess, done. So yeah, let's see what this problem is about, right? So I guess optionals, we saw something like this in the compiler project, and it's like question mark is the same thing as having optional from Rust, right? But it has this new I guess null keyword as Golang. So not really a huge fan of having a null, but yeah, whatever. I mean, as long as it has a meaning, like with this question mark, then it's better to have it's not as bad as Java, right, to have nulls. So threaten the result. Oh, so it's or else. Nice. So that's why it said that threaten the result. Get the result or else this is gonna happen. Okay. 46. Right. So we also have dot question mark. Yeah. I mean, I would have preferred if yeah, so I mean here it's like dot question mark obviously, but right, why wouldn't they use the same method as for errors with try? I think would have been nicer, but whatever. Oh, what? Tail needs something. Wait, do you literally have to say it's I don't get it. Or is it like pointer to and then question mark? It's not obvious at all, like what? Expected type found null. I mean, the hint is cannot be like this, right? Like, I want to say that this thing is optional, but I have no idea how. Was it in 45? I don't think so. Why isn't it like that? We should stop. I guess A points to B and B points to C. That's enough. Huh, I thought that... well, I guess this works, right? But this thing should be different. But what? Or else first elephant, like... I mean, that would make it work, I guess. But pretty weird. Whatever. Yeah, whatever. Okay, so you can have functions on structs. So it's like OOP already. Pretty cool. Oh shit, it's like C++. Oh no. I mean, we hate this method, what? Hatch. Yeah, okay. I mean, so I guess, you know, hit. Interesting. So make a pointer. So if you put a reference here, it's like doing itermute, right? So you can get references to items from the array. Yeah. I mean, that's useful. Obviously, we needed that. Okay, so the next one, 48. And this is or else unreachable. Okay, whatever. Okay, let's see. So get tail returns like a new, like the next one, right? And has tail returns a boolean. Visit, set it to visited, and print shows it, right? So that's what we need to remember, I guess. So if E has a tail, then we can just call to get tail, I guess. your elephant trunk method goes here. Okay, so we need to do some method. Wait. Oh, so it's now I get it. Tail is like, it's like a doubly linked list, but with yeah, whatever. So let's do like pub fn get trunk. Right, should be pretty self-explanatory, this one. So it's like with unreachable. Okay, and this one checks if you have a trunk. Yeah, should be like pretty simple. No value, Oh my god, 4 ways of saying no value. But I mean, you know, kind of weird to say that because this is a new 8 and this is a optional U8, so it's not really another way of saying no value because this is a different type. When I saw like 4 like this is yikes. Void? What the? Okay, so it's like undefined. Obviously it kind of makes sense, you know, in a C-like language to have undefined, and it's especially cool because it's 0xAA, right? A bit better than random in C, so at least it's like that, right? It's easier to spot if you have undefined values. But I mean, I wouldn't have said that null is another way. It's like a different type. Then you can have like errors and void. I guess it's like unit. Yeah, I mean, I don't know what void could be useful for. Yeah, that's what it would mean, like there's never gonna be a value in here, right? So this one should be undefined, right? Because it's like a type. Since this one is a error, then we need to initialize with an error, right? And this one seems to be returning void, am I right? And here, since this one is optional, can be null. Interesting. '51 values. Huh. Okay, so like some character, we have the narrator. So since it's a var, yeah, whatever. Like a big story, but pretty cool. I mean, I don't know. I mean, it made sense that when you import something, it's probably like a struct, right? It's kind of weird. It's like it's JavaScript. Yeah, so we have like these structs, we have a variable here. I'm curious, probably whatever is not initialized is set to undefined, right? So character, for example, like global wizard. Then glorp is gonna have a couple of undefined fields. So we can assign functions like this. So glorp, I mean glorp, it seems to be like a variable, so should work. Okay, I'm curious what's gonna be printed though. Let's see if it works. Okay, so I mean, good question, right? Like, since this is a struct and it's not a pointer, I think what we're gonna see is that this is gonna be a copy. So the value of gold that we had before, which is 30, is gonna be different than 111. So right, and yeah, here it's a pointer. So if we change the amount, should change both of them. And here we have a const. Which is fine because we don't change the value of the thing itself, we change the value of gold, right? Yeah, that's what it says. I mean, obviously, like, oh shit, this is like, wait. Damn it, it's like TypeScript. But I mean, you know, it makes sense. Yeah, so if you do like const pointer, then you cannot change the value inside, right? So level up. Okay, I mean, I saw here an error, so it says cannot assign to constant, right? XP before, I'd say it needs to be a pointer, right? To be able to change it. So it's the same thing as in C. You need to pass the reference. So let's see if I was right about the... So first it's gonna be false, right? Because we changed, or we created a copy of character. The second one is true because we have a pointer, and the third one is also true because we have a pointer. So yeah, we have even though like this just means that the pointer can change, and this one means that the pointer is gonna always be glorp. What's his name? Yeah, so makes sense. I mean, pretty standard stuff. First 4 cards, okay. So, I mean, or like this, no, 0, okay. And then 4 and the rest. I mean, it makes sense. It was either with colon or with dot dot, so it makes sense. Okay, I mean, this one should be like this. Under the hood, slices are a pointer to the first item and the length, so it's pretty funny. DSH. A slice. String slice. It's a pointer to the first thing and the length. Yeah, pretty funny that I had the same idea. I mean, it's string slice, but when I implemented that, okay, whatever. 0. Which one is the next one? 53. Slices on strings. I mean, just what I showed you 1 second ago. Okay, I mean, it makes sense, yeah. I mean, it's a good thing that strings are immutable, honestly, so yeah, so it says that you just need to add const. Like, do everything, what? Kind of. Oh, obviously, yeah, it's also. Let's not forget about function parameters. Oh, whatever. Many pointers. Okay, this one is interesting. So we can have like an array of fixed size, I guess. A slice. This looks like a pointer to an array. And this one is another slice. Okay, whatever. So this is like having many pointers, right? Like an array of arrays, pretty much. Take a good look. Okay, whatever. So wait, what the hell? What a complicated way of doing a string. So it's this is like the characters, and then it's a const pointer. this is what I would have expected to see, but kind of a weird type, holy shit. Whatever. So this would be, let's say, like the first element, right? It's constituent. This is a pointer. I feel like it's missing the end here, like this symbol, but whatever. So it's like, I mean, pretty sure it should be like 0, like the first one. Oh, so a cheat sheet. So this is a 1U8. I mean, pointer to 1U8. Okay. Pointer to unknown number of U8s. Interesting. I mean, this one is useful. Yeah, right? Makes sense. So pointer to unknown number of immutable U8s. Like a string. Oh. Wait. So that's pointer to unknown number of immutable U8s. So this is like a single string then. Yeah, pointer to an array, pointer to an immutable array of 2 U8s. So this is like a string, right? Because it's immutable and it's an array of U8s. And this one is a slice. Constituent. Wait, so it would be so expected this type but found this type, right? I don't know if it's okay, makes sense. Found a single U8. So then how can we convert this thing to the right thing? I mean, right, because we need it to I mean, yeah, if I would have read the description, I would have known instantly that this is the thing. But yeah, it's like, if we look at this one, it's an unknown number of characters, right? That's what this pointer means. So we convert something that we know the size of to something that we don't know the size of. And then we convert it back. I mean, we take a slice from it. Okay, makes sense, I guess. You know, like, looks decent as a syntax. Let's see what this one is about. Oh, a union. Okay, I mean, unions seems to be the same thing as in C, so it allocates memory for the largest thing, so U64 for example, and then depending on what you use, it chooses that, right? Medium. Wait, why would it be an error? because we already use small, right? In a way this one is nice. So once you declare it with a field, you cannot use the other ones. You know, when you see, I had the problem of mistakenly using the other field, right? So it's good that you get a compiler error. I think it's right, it's a compiler error. So it's like polymorphism. I mean, it's polymorphism is useless, but whatever. So we have insects, still alive, flowers visited. Since we need to specify enum. Interesting. So oh, it's like A or B, right? So it's okay, makes sense, right? So here we define ant with still alive and B with flowers visited. And in here we switch over the type to know which field to access. So I'm curious, would it be a because it doesn't seem like a yeah, it's not a compiler error, but at least it's an error nonetheless, so that's good, right? Okay, let's see if the next one tells us how to switch over the thing. So we have a union with an enum, okay, tagged unions. Okay, makes sense. So we can use a switch on the union itself. Okay, makes sense. So we have insect stat, print insect, and B, and here we need to switch insect. Wait, yeah, switch on the thing itself. Yeah, I mean, you know, made sense that optional and errors are like tagged unions because that's what they are in Rust. So, which I think is the, I mean, in a way, I still think that's the better way of implementing them. It's like they are part of the types in language, not necessarily keywords. Okay. So insect stat, we need to define it. Oh, that's cool. So we just say enum, and wait, this one is kind of yeah, I mean, so this is how you define enums from Rust, basically. yeah, it's like some types variants. I mean, yeah, these are all or even enums. Yeah, making fun of functional bros. Okay, 58. Okay, let's go to a place that's actually broken. Pretty cool. Yo, but oh my god, this was like a flashback to, if you know, you know. I mean, there's no way someone would, yeah, whatever. Oh, so it's like a graph problem. And yeah, it's doing a BFS, I would assume. So P is undefined. Oh, what? Wait. Union values in a switch. Oh, it's nice that you know, it's the union here and it has a function. Please capture both values as P. Wait, what? Was it in 57 that I missed? Oh, so you just have to do it like, okay. Like a lambda, okay, whatever. So, still has some errors. So online 414. And it says that expected union type found void. Get trip to. So it's probably that this one needs to return trip error. Right. Okay, this one is the other way around, like the thing that I was doing wrong earlier. 258. Wait, what? One second. So entry is the thing that we get, so it's a pointer already. So here we dereference and take the optional. So entries, oh yeah, I mean, you know, the error message is probably better. So expected like this, but found it like this. if place, okay, so place is a const pointer place, right? Oh, we want to return this. So it says question mark pointer but found pointer question mark. Oh, okay, I get it. So we dereference it, we take the thing, and then we take the address. Yeah. Okay, cool. So it's like, yeah, whatever. It's a bit, I would say it's a bit more difficult when you have a humongous program and you don't know what it's about, but yeah, it's okay, whatever. Alright, so in this one it looks like we have maybe something with integers, not sure what it's about. Oh, so we just please fix the message. Okay, I mean, I guess we need to show Ziggy school or what? I mean, we just need to add one to everything, right? Yeah. Oh, floats 060. I mean, the thing about flows, right? This is the IEEE stuff. I mean, it would be interesting to explore how IEEE works, but in a separate one. So here it complains that it's infinite, right? And I would guess that's because of the data type. I think that, right, it should depend on the F type. Wow. Wait, what? Hex floats? That's pretty cool. I mean, whatever. Yeah, so maybe we don't have enough precision, right, to uh, multiply with this number. Right, so let's say 32. Honestly, I'm not really, like, this is not really a zig thing, I would say. Whoa. So maybe it was just decreasing this thing, right? So it looks like it's I'm not sure. Maybe this is how you do it, but no idea. It's like, yeah, whatever. Like I would say that float numbers are the same in any language because they are gonna be compiled to assembly floats. So who cares? Coercions. Okay, I mean these ones should be pretty interesting. So there are like some rules, right? I mean quite a lot of rules, honestly, compared to Rust, for example. But it says that you can make types more restrictive. So you can change from normal pointer to a const pointer. That makes sense, right? Then another thing is integer widening. So you can convert from U8 to U16 or stuff like that. It's pretty, I would say it's pretty standard so far. You can go from slices. I mean, this one is just definition. So you can convert to a slice or to a many item pointer. Which, I mean, I'm still not sure I understand the difference between a slice and a many item pointer. They seem to be the same thing. Or, huh. Like, yeah, no. Slice has the start and the length, and many item pointer has only the start but doesn't have a length, right? That's kind of the difference, I would say. Yeah, this one makes sense. I mean, if you think about it, a pointer is just a single item array. So it's like a good view to, like, maybe it makes sense to know this kind, like this is like an Easter egg in C, right? Like a pointer is a pointer to a number is like an array with a single element with that number. So payload. So this one, maybe number. Oh, Haskell. Yeah. Let's say that this kind of makes sense, right? Because you put a number in an optional, so yeah. Yeah, like it kind of makes sense, right? Because you put a number into an optional. Then for the next one is like the errors, which also makes sense to do the same thing. And undefined courses to any type. Yeah, obviously. Compile time numbers. So we'll see compile time stuff soon. Tagged unions, yeah. Enums course to a tagged union when the tagged field is a zero length. I'm not sure I understand this one. Okay, so we have a pointer to a letter, right? Oh, so we have to build a type that works here, right? So it's gonna be optional, right? We can also dereference it and take the first thing. So 4 and 5 rules. Yeah, I was thinking about maybe it's gonna be this and also optional, right? So since we do optional first, it's probably gonna be, let's just copy paste this thing. Let's see how it's gonna look like. And maybe it's gonna be also optional. So that's what I'm seeing here, like question mark. So it's gonna be optional. Then we dereference this thing and then we access the first element. Hopefully that's the way of doing it. Yeah. Loop expressions 062. Weird. I thought we already looked over loops. Yo. Prologue. Maybe we can try this language. I mean, it's pretty cool, but I don't remember how it was working. So, 3-letter name. Makes sense. Right. Oh yeah, this is... Oh shit, with break. Really? So this is what I was searching for, right? You can break and put a value to break with. Yeah, that's pretty cool. Or, not sure. I'll have to see, like, experiment more with this kind of stuff, because this is what I would say would be pretty cool, right? To have, like, everything is an expression, and you can return stuff from the for loop. So that'd be cool. Wait, what's the issue with this? Wait a second. Expected type found void. So it's not how it works. Oh, implicit else void. Huh. Oh, so I should maybe do else null, right? Okay, makes sense to me. Labels 063. So we can have labels and then breaks out of a certain label. This one is pretty neat because I like, it's really often it happens that I have two for loops and I want to break out of both of them, right? But you have to do scuffed like if statements to break out of two for loops. But maybe this one helps. Like, makes sense that this would help there. So let's see. See, like this one goes to food loop. Where is food loop? Or should I? Oh yeah, see, this is kind of nice. If not found, continue to food loop. Wait, where's how did? Okay, yeah, like that. Please return this food from the loop. Oh, so this one is food loop. Okay, okay, okay. So I would have to return food, right? I think. And by default we return mac and cheese. So I guess food one, or it's like menu one, right? Or something menu one. Nice. Cheesy chili. 064. Ew. Oh, it's like expected result if there was no overflow. So what's A? Ah, I get it. Yeah, so if you want to add 4 to this thing, so 5, then you do 1 here, and then is another 1 here. So it would be 1001 is like the other way around. So maybe 0p, right? Bit reverse. I mean, it says Ah, interesting. Bit reverse. Not sure what I would use it for. Buildings too. Yeah, not sure what this would be useful for. Because it's not like a little endian to big endian or something like that. It's just bit reverse. Yeah, whatever. So we cannot leave the me and myself fields undefined. Why not? I mean, I would just do Narcissus, right? This one was like echo, or no? Wait. Fields. So it's like type. Hmm. Yeah, it's pretty neat that Zig has these types as values. Wait one second, just to look again at the stuff because it's interesting. Yeah, call compile time. This type. Oh, so this is like returns this thing's type. It's like size of basically, but instead of the C way of just returning the size of a thing, it returns the actual type, which is much nicer. And type info returns information about any type. Yeah, whatever. And type of. Oh, nice. So it's like the common type or something. Okay. So standard practice in Zig is functions that return types should start with capital. Okay. But I'd say that this one should be like this. Also type of. Right, if we take a look at each one of these, we should get type 1 being equal to Narcissus or something, right? Because it's the common type of all of them. Type 2 is like this type. Right, something like that. And I mean, yeah, this one could be like a 4 through all the fields, but No field or member function named like that. What is the most beautiful type? Is not a member function. Uh, I don't think it needs to be public, right? Okay, I mean, what? So on line 50 it complains about something. Oh, it needs a self parameter. Do you have an example? Because I don't know how to. I mean, pretty sure that we had examples with methods, right? Okay, makes sense. So you just put self in the thing like this. And then what? Self? I don't get it. Okay. So the fix for this is very subtle, but it makes a big difference. Yo. God damn it, I don't get it. Comp time. You know, I mean, I don't get it. So it's like I shouldn't add this one then, or what? Because it's like what like this. So yeah, I mean, I don't get it. No field or member function is not a member function. Like, did I miss anything in 064? I don't think it's No, I don't get it. We called it as a method. It's like what should be called on the thing itself, like on the type or something. Oh, I mean this pretty lame, honestly. So if it doesn't have a self as the first argument, it's how to call it in Java or C Sharp? Is it like a static? It's like static methods, right? Or class? I don't remember. It's like static methods or something stupid like that in OP. Uh, yeah, whatever. I honestly I don't see the point of having static methods, but whatever. I mean, since we can have functions, what's the point of static methods? So yeah. Okay, whatever. So compile time. So all the numbers are compile time int. Yeah, whatever. So we can do comp, const int, const float. But if we make them bars, the literals are still compile time. Okay. Also, you just need to specify the types. Right, so it's like, okay, this should be a U32 and there's probably an F32 or something. So like this, right? Yeah. Oh, comp time int. Interesting. 67. Yo, nice hash chart. Okay, so in this contrived example, what the hell is this? I mean, I don't know, whatever. We've decided to allocate some arrays using a variable count, but something's missing. Let's try to see if we can figure this one out without, I mean, without a compiler, pretty hard, but is it the problem that comp time? Like, is it a problem that count is gonna be variable in this? So variable of type must be const or comp time. What if we say use size, for example, right? Like that would be my first instinct. Unable to resolve comp time value. Array length must be known at compile time, right? So that's what usually happens in C. You cannot really define an array like this with something at runtime. So comp time we just need to say that count is going to be used only at compile time. So it means that everything that's in relation with count is going to be executed while we compile the code, right? So all of this is just gonna be like converted to, this is gonna be converted to 1, right? Something like that. While we compile the code, basically. That's pretty cool, right? And then it's a bonus. Okay. Yeah. Yeah, whatever. So, it makes sense, right? 68. Oh, 068. Compile time part 3. Okay, so we don't use my scale. Yeah, like it's cool. Imagine having like code that executes only at compile time. It's like all one code. Anyway, create a scale of 1 to 0. Oh, compile time error. Wait, what? But how would it? Oh, since scale is compile time, okay, it makes sense, right? It's probably the correct solution most of the time. It sets a 0 scale to 1 instead. So just say my scale is equal to 1, right? Is there anything else? What would happen if you did attempt to build a model? You are cooked. You are already done. Mental device. I mean, like the correct option is literally you are cooked. How about a model in the scale of 0 to 1? I mean, this is a funny one. Okay. So if I run this thing, wait, what? Declared compile time here. Okay, I mean, I declared compile time, whatever. Scale me. Wait. Oh, so this needs to be comp time. Right, make it comp time. Yeah, pretty cool. Another one, 69. Yeah, it makes sense to have like a type being compile time. It's like generics or something like that, similar in a way. Okay, so types are only available compile time, even though you can have types like values, you cannot really use them like crazy in the code, so sure. Okay, please fix this function so that the size parameter is guaranteed to be known at compile time, so it needs to be comp time. set the size of the array of type t. So this is gonna be com time, and it's gonna be use size, right? Use size. Wait. I mean, this one is gonna be size, but here, what the hell? I mean, oh, I can use size. Well, actually, it makes sense because here we have t, and we use t here. So that means that we can also use size. Okay, so it's exactly like generics, but it looks a bit better in a way than usual generics. Uh-huh. 70. I mean, compile time is a huge thing from what I can see in this language. Eggs. Which, I mean, you know, the compile time seems pretty cool. Probably lets you do a lot of cool stuff. Okay, make sure my type has both waddle and quack. Okay, whatever. Let's see what this thing is all about. So, oh, has field, has decal. Okay, so these are gonna. It's, you know, the first thing that I had in mind when I saw these two is like traits in Rust. It's like has decal is probably gonna be something like a type that has this function, right? Or something like that. Yeah, pretty cool. Okay, walks like a duck. I would say has decal. Okay, nice. So, oh, container type. So this one is interesting. Ah, my type, right? So make sure my type has both waddle and quack. And for this one, it should be an array, so it's like, yeah. Has decal. Not sure how I feel about this, but if it works, right? I mean, still pretty neat. Wait, what? Wait. Oh, so it's like, it's yeah, whatever. I saw the example here. Interesting. Yeah. So it's type info. Oh, so this one is the one with the for, right? So for, and then we can say fields, and we capture it. So Yuck, exactly. Inline. Ah, interesting. Inline. Oh, yeah, this kind of stuff pretty cool. Can I say? $72. Oh, this is like the spoiler, right? Whatever. So in this one, if I wish to loop over each instruction in the string at compile time. Loop over each instruction. Inline while, right? So an inline while loop runs at compile time. Probably is gonna be I plus plus or like plus equal 1. Can you figure out why we subtract 0 from it? It's like the same thing as in C. It's not anything special. It's like instructions are gonna be numbers, right? And when we subtract 0, we get... Oh, what? It's pretty weird. Well, I mean, you know, we do multiplications and stuff, but what's weird is that these things don't change. Yeah, like this, the instructions does not appear anywhere in the compiled program because it's not used. Interesting. Oh, actually, yeah, I was looking at it wrong. It's like digit, right? We subtract 0 to get a digit, and then this is like that. So it makes sense. Okay, so something's still not working. Overflow of integer type. U8. Well, that can't really happen unless we need to add 2 here because we have spaces, right? Wait, do we need to add 3? Because it's like instruction, number, space, right? Off by 1 errors. What can I say? Okay, now it's 73. Yeah, from what I can see, compile time is a big thing about Zig. Yeah, pretty useful, but so maybe I have to think of an interesting project that can benefit from compile time stuff. Like how about maybe implementing something that runs at compile time, but that's lame. You can put compile time in front of any expression. but I'm pretty sure we meant to fetch the last. Okay, let's see what the error is. So, what can you make with the I parameter above to make this so? Uh, pretty weird. I mean, 5 here is a compile time number, right? I'm not sure if I'm supposed to say here comp time or what. Maybe that's what I'm supposed to do, probably. And this one should be 4. Unable to resolve. Oh, what? Make llamas. Oh, it's the next one. Yeah, I was just looking at it because here it says execute a function, but we don't really need to execute a function at compile time. We just need to say that I is known at compile time. Okay. 74. Okay, make llamas. Yeah, since it's used in here at the return, it needs to be comp time. And even here, this does not need to be an inline while. Sure, why not? Yeah. Okay. So that's that. 70. Oh shit! Another quiz. Oh no, it's the big one again. Yeah. Okay. And we're only going to change one part. Phew, perfect. Um, honestly, I don't remember, but whatever. Fill in the body of this function, so only this function. Oh no, it's freaking a star. Okay, so let's try to do that function, right? So we get a from and a to and a distance. And we want to create a path. Where is make path called? Also, it needs to be compiled time since we initialize stuff like this. I mean, but I would just say this stuff that's there, like path. like this is what my, probably return, like this is what I would do. The fuck? But it's not, whatever. Zero 076. So this one, like sentinel, it's the end of data. Yeah, like null character and so on. So here is a zero terminated array. Oh, so this is what this is about, like colon and then the sentinel. Okay, here is a zero terminated many item pointer. Okay, so this is how you would use this thing, like star, and you say which is the last item. Okay, let's replace the value at position 3 with a 0. Attempting to loop through and print. The reprints completely. Yeah. So, oh shit. Print sequence. Missing my sequence. Because this loops through a list. Like, interesting, even though you say that it has a 0. Huh. And this one is probably my sequence. But if you make a while loop and check for this thing, obviously it's gonna stop at 0. But yeah, I mean, makes sense. Top secret. Oh my god, they are just silly literals. But wait, a string literal is a constant pointer to a zero terminated fixed array. Interesting, why does it need to be null terminated if it has a fixed array? Yeah, I mean, exactly my question. So it's gonna be compatible with C strings. Okay. So you can do stuff like this. Okay, let's see what we can do here. So weird container, right? Of course I remember how to take a slice. So I'd say foo.data and then what? Foo.length, right? Mm-hmm. 7, 8. Oh, and this one again. I mean, you know what I mean. We've called the sentinel terminated string to a many item pointer. Okay. cast data to printable. So it's like pointer cast. ptr cast. And here let's say data. Oh, yeah, because this one doesn't have anything here and this one has, so it's more strict, so you can cast to it. It makes sense. Quoted and whoa, quoted identifiers. Well, no, I always wished for a way to have stuff like this, but would I really use it though? Not sure. I mean, you know, it's a pretty cool gimmick, but you know, anonymous structs. Obviously, you can just say struct. Like this looks like something you would, you know, kind of have to have in a language. Anonymous things. Uh-huh. It's a red flag. Yo, I mean, it's crazy. Let's not look at it because. Okay, so I still made an oopsie doopsie. Wait. Oh, but it's pretty interesting. Whatever. So it's gonna be circle, right? And we call to the function to get a type. Huh. Yeah, this is like a constructor, right? Still doesn't work. Oh, I need to pass in a type. So for example, this one is I32. So it's like generics all over again. Cool. Print circle. So from earlier, basically. So circle. And I would, okay, it needs something. Oh. So it's like what, any type? In don't really like any type, but whatever. Hmm. I guess you can have checks and all of that good stuff on any type, but yeah. Okay, so the next one has a bug here. get a list of fields in the input tuple. Okay, so type info. Okay, let's see how a tuple looks like. So it has true, false, something, something. Okay, so I can access fields like this. Perfect. Oh my fucking god. Okay, whatever. Okay. So I would say probably it's something like, to get the tuple. Wait. Oh, so that's why they needed quoted variables because of tuples. Makes sense. So we want struct field is going to be an array of struct fields. Type of takes a value, returns its type. So if I do type of this thing, we'll get back the type. And if I do type info struct.fields, I should get back the fields of the first thing, right? Okay, makes sense. Uh-huh. So in this case, I'd say maybe first thing was what? The name or the value? I think it's the default value first. Default value, then it's name, right? And the value itself. But how do I get the value itself? Oh no, wait. The first thing is name, then it's type, you'll need this built in. So field, left hand side is any type, compile time, field name. Yo, what the actual fuck? Oh, so it's field tuple, right? And in here we should say field of name. now I'm not sure if this is gonna work even for one. Access of union field struct. The fuck? So then is it only this? No idea. So this needs to be inline. Oh, what the fuck? So maybe I don't even need that. Maybe I have to do struct fields like this. Fucking got it. Yeah, easy. So we got the type of the tuple, and then we got the fields, right, from the structure. Yeah, I mean, I'm never gonna use this thing, but whatever. So this one is anonymous list. So, oh, this is a tuple, but it's in quotation marks, so maybe it's still a list. Without changing the value literal. So what does it do now? It complains that it's a, oh, it's a structure. Okay. Please make hello a string like array. I know how to do that. So we take this thing, right? We run it on hello. We get the fields. Then we do an. I mean, is it though how you do it? Because it's the destination type, right? So can I just thing and then say 5 u8? Right? Can I do this thing? Yeah. Cool. Wait, why does it skip this? I mean, interesting. So 80084 would be the next one. I'm not sure why it was skipped, but whatever. 6 facts. Yeah, whatever. Stack frame, return pops. Okay, yeah, makes sense. It's like the usual stuff. Suspend. Oh, I wonder how we'll go back to the execution. Interesting. So foo that suspends. Oh, but oh my god. It sucks a little bit because how do I know that this is an async function? given facts 3 and 4, so it's like you can use suspend and async. So foo seems to be async, right? So I have to call async. I'm not sure why it skips those 84. Maybe it's like I have to do 92 and we'll come back to this one. I don't know. Let's see, interfaces. Okay. So interfaces was a thing that I was thinking about because of the traits in like you do in Rust, but we want to print each insect. Oh, so we have print on all of them, right? So it's grasshopper, bee, ant. All of them have a print. And then we have a bigger print for an insect. Oh, so this is like an interface then. Interesting. Okay. So it's just insect.print. Doesn't contain underlying data in the print. I don't know, but it makes sense. Right, to have stuff like this and then have a tagged union. And then the print statement just calls to each individual function. It's a bit more overcomplicated in a way than just having traits, but whatever. So, oh, hello C. Cool, so we have like interop maybe. UniSTD, nice. So maybe we need something like C something around the code. Oh, it's C dot write, right? So it's this easy to just use C in Zig. That's pretty neat. That's pretty cool. So it means that probably it would not be that difficult to run Zig on embedded then. Yeah, I mean, pretty nice. Like, I can see this as being as trying to build an improved C compiler, basically. But 9.4. Oh, oh shit! What do we need to import here? Obviously, math.h. It says that it's something about a math. Wait, fmod. Wait 1 second. So it's math.h. Nice. I mean, you saw it's a bit slower for some reason. Not sure. 95. I want to print every number between 1 and 20 that is not divisible by, oh, hmm. So it's like adding a filter. You know, I would probably do something like this. Ah, okay, whatever it is. So it's just this. Memory allocation. Yeah, boy. So let's see if we have malloc. Allocator dot allocate. Oh, probably it's alloc. And we need to, it's pretty nice. You say the type and the size, so it looks really similar to malloc, but I like that we can have types instead of size of. That's always nice. So F64, right? And then how much? No idea. Doesn't really say. But it's pretty cool that we have that. Expected found. Oh, so it can also throw an error, right? Out of memory. So we can just try it. Oh, I need more numbers then, or what? Double the amount. Oh, it's too many. It's 1, 2, 3, 4, 5 numbers. So it's probably the same size as this one. Okay, bit manipulation. So we swap the values. Wait, what do we want to do? Oh, swap. So we do x XOR y, y XOR x, and should be again like x XOR y, right? Or something. The trick. But I saw that reel from that short from the Primogen about swapping. Yeah, maybe this is where he found that. I don't know. 98. Return bits. 0x. Okay, that's oh, because it's in hexadecimal, right? But what? Okay, so first we check that the string is at least 26 characters. Pangram? What the fuck is a pangram? And last we return the comparison of all. Let's check the pangram. The string has at least 26. I don't understand what this wants. Alphabetical character. I don't know what the x does though. Like what, 26? What the fuck is x? Yo, what the fuck is this exercise? Like it's so out of nowhere, right? Like what does x mean here? Can I put a 1? See, it doesn't work. So actually I guess it's like just a number, so you put something like this and it's like cheating. Oh, so I have to figure out what number to put here, right? So if all of these bits are set, actually let's use Python for that. So we should have 26 ones, right? Damn, how can I do that easily? Because I don't want to do it like this, it would be crazy. But maybe it's not that difficult. So let's do 26, let's do 2 of them and then copy it 13 times. 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And sure, if you want to do it like hex, we can have this number, right? Yeah, weird thing. Formatting. So print a header, whatever. Print header row with all numbers from 1 to size. Now the actual table, is there anything more beautiful than well formatted table? I'm not sure, maybe. What formatting is needed to make our columns nice and straight? Well, the Pride Month, am I right? So it invalid format string, question mark, question mark. Okay. Oh yeah, I know. It's D. Let's see if I remember. So we need some padding, right? So like if I remember correctly, this was the padding amount. 1 second, so it doesn't work. So I need more padding. Looks like I need something like 3 is like the amount, or maybe even 4 if it's the same amount as that. Oh, it's too much. Yeah, maybe 3, the magic number. Right? Yeah. And that was just because I saw the size. Oh yeah, it's actually like this. So nothing special. 100. So the new and improved for loops. Oh, nice. So as I said with Z. Right? Yeah, no, I would guess that if you have a shorter array, it's gonna stop to the shorter one. Oh, interesting. So it's actually a compile error. Hmm, I don't know. Sure, why not? It's a nice change compared to. Oh, so roles, gold experience. No, because I was like, if you do this, right? So I think that's the only thing that we need to add. Because I was used to, I saw that you put an infinite list and it gets the shortest one when it does the zip, but it looks like, whoa. But what the hell? Bro, they are the exact same thing. Am I? Oh, so it starts with one. Okay, 102. So let's see how testing is done in Zig. Pretty sure it's like Rust, yeah. Cool. Wait, what? Try error division by 0. Nice. So yeah, since errors are values, must be much easier to test the error cases than other trash languages like Python. So for sub, wait, what? Test subtract. What is that? It's fine. Okay, nice. Tokenization 103. Interesting. Let's see. I guess this is like working with strings. Tokenize any. So what do I want to tokenize by? Space? And then we have a counter, the iterator. Cool. But didn't work. I wonder why. Expected type. Oh wait, it's an array of delimiters. An array of delimiters, okay. Const UA does not support. Bro, what the fuck is this? Oh, it's a. Oh, wow. It's like a string. Interesting. Oh, so we also split by the other stuff as well. So, comma, or the punctuation stuff. And even new line. Yeah. Oh, trading. This one's probably cool. Yo, what? Oh, that's a nice diagram. Defer, obviously, handle trade and join. Yeah, for trading, defer is pretty cool. Oh, what's thread function? Thread function gets in a use size, so -4, yeah, it won't work. Let's put a 4. More management is required. Huh, whatever. Oh no, I did an oopsie doopsie. Oh, it wants to be called thread 2. Okay. Hmm. 105. Threading part 2. Oh no. Okay, second thread to calculate the minus numbers. So it's like this thing minus this thing. Okay, okay. How to compute pi. Okay, so const handle 2. So I want thread pi probably. Right, the function. Then we need arguments. So it's pi minus, right? Begin. Wait, it's plus pi plus 4 divided by. So we begin at 3. And we have count. Something like this. And then we defer to join. Right, so if we start at 3, we sum up this thing, okay. Let's see if we got pi. Man, 104 is gonna be slowing us down. Okay, nice, we got it. 106 files. I think we're pretty close to done, right? Oh, shit, it's only 2 more. I mean, threading, no, pretty standard. It's exactly like C. From what, the stuff that I see, like first try. So this might be the error, right? We get the current directory and we try to make output directory. So we need to handle the error. What errors can we get though? Oh, path already exists. Okay, and in case we find this error, we don't want to do anything, so it's just squarely braces. Then here we try to open the directory, we defer close, cool. We create a zigling.txt and we close it. I mean, here we can defer it because we try to write the file. It's zigling time. Yeah. So defer might make sense. Yeah, I mean, if you want to also read from the file, that's pretty interesting. But I mean, we kind of handled a bit of files in the compiler, so I'm not really like, oh, I need to learn about files. It was pretty much the same. I mean, files is pretty much the same every time. So, but still, we did a fucky-wucky. So when we open a directory, we have to try. Yeah, I'm not sure why 104 is slow, but whatever. Okay, and the last one of the files. Read the file or I will fight you. What? Create a file, right? With content is zigging time. I mean, come on. Missed opportunity to call it it's zigging time. There's no point in writing to a file if we don't read. Am I right? Yeah. First, open the directory. Open the file, initialize an array, and print it. Okay, so I think we try open the file. Wait. Huh, I thought it was 2 stars, but whatever. Seems like a threat of violence is not the right answer. Oh, let's see. So it's right. Wait, why is it for Windows? Because I would use read or read all. That's what I remember from the compiler. So let's say I'm gonna use. Can I go stdfs.read? Wait, what? Oh, so it's on a file. Okay, so file.read. And we need to pass in the buffer. So address of the content. And it can return an error. So we try to read it. Oh, another one. I mean, it says that it's 18 byte, so I can just hack it. Wait. Oh, so yeah, that's what I thought. Something's scuffed about that. Oh my god. Oh no. I don't remember. So this is what, well, this was the way of but can't I just, hmm, oh shit. Expected but found some weird ass stuff. Oh, and even then, I think that's how you initialize it. Hmm. But like, thought that because I searched for that. Is there a to repeat? Huh, so strange. Why wouldn't this one work? Oh, because it's immutable, right? Shit, so something like this we need to use. I need to specify u8. Oh my god, there was oh, I put two G's. A way to run only one. Okay, like this. So 107. Hmm. Oh, yeah, really annoying. Oh, so it's like struct. But wait. No, I mean, did this one before or something like that. But it's like, I don't remember how I wrote it in the brainfuck compiler. No, I mean we can just go to bf compiler, zig, Okay, so like this I initialize the stuff. And then I read it like that. No, it's not cheating. Chill, chill. I mean, should it be var? I can see the exact same thing. And then pointer. Okay, cool. Yeah, sure. Cheating. Not really, I mean, already wrote that. Forgot how to do it. Oh, pretty cool. I mean, there were still those ones with uh, async. But not sure about them. Whatever, let's leave them. Let's say that we actually managed to get at the end. Yeah, I mean, yeah, I'm gonna say it like after solving ziglings, I wouldn't say it's enough to know anything about the language. Like, to be fair, I think it was more fun to do the compiler, even though it's like yeah. So yeah, as I said, if you have any suggestions, like what would Zig be a really good choice for? Because yeah, for the compiler, I mean, it was fine, but it wasn't any different from C. Like it felt the same. Maybe with better error handling, but other than that, I mean, yeah, at this stage I didn't really know about compile time stuff, so maybe if I would do it again, I would try to use compile time more or something. But still think that maybe, you know, there's better use cases for Zig. So yeah. So if you like have any ideas what would be a good use case for Zig, sure. Like for example embedded, let's say. But yeah. So sure, we'll see in the next one. Bye.